Let's start with the principle of superposition. Principle of superposition. So first, the statement. The statement of principle of superposition says that when two or more waves meet at a point, the resultant wave has displacement which is equal to the vector sum of the their individual displacement. So the key terms in this definition are meet, displacement, and individual displacement. So let's see some examples. If we have a wave with positive amplitude A and another wave with a positive amplitude A, the resultant wave would be a positive amplitude with amplitude 2A. If we have a wave with positive amplitude A and another wave with a negative amplitude A, so the resultant wave would be none. If we have a wave with positive amplitude A and a negative amplitude of 2A, so the resultant wave would be a negative amplitude of A. As this is minus 2A, this is plus A, so 1 minus 2 is minus 1, so minus A curve, the wave would be positive. So if we have a wave positive direction 2A and another wave in negative direction A, so the resultant would be in positive direction A. So let's move on to the next topic is principle of superposition. Let's first see the conditions for interference. So condition number 1 is that the wave must be from coherent source. Which means that they have a phase coherence. Number 2 is that the waves must meet at a point. Waves must meet at a point. Number 3 is that wave must be of same type. So let's see the types of interferences. Types of interference. We have basically two types of interference. A is constructive interference. And B is destructive interference. Destructive interference. So constructive interference first. Constructive interference. The definition is that the superposition of waves which support each other to provide a resultant wave with greater displacement is called constructive interference. Now let's see the conditions for the constructive interference. The first condition is the path difference. Path difference is the difference of the distance of two meeting waves from source to meeting point. Do bear in mind that path difference is represented in terms of lambda or wavelength. Now the second thing is phase difference. Now the formula for phase difference is phi, which is the phase difference, is equals to path difference divided by wavelength multiplied by 2 pi or 360. So we have two waves S1 and S2, both have wavelengths 1.5 lambda. So the path difference is 1.5 lambda minus 1.5 lambda, which is 0. So the phase difference becomes path difference by lambda into 2 pi. So that is also 0. So that's it for this video. In the next video I will continue with this lecture. Thank you. Do like and subscribe my channel for more videos.